As we continue our study of area, today we're going to focus on trapezoids, kites, and rhombi. The area of a trapezoid, the formula for that is that the area is equal to 1/2 base 1 plus base 2 times the height. Now you can multiply those in any order. You could also see it as base 1 plus base 2 times the height all over 2. However you want to handle it. Of note, base 1 and base 2, it doesn't matter which one is called which. Also, it doesn't have to be turned that way. They can be turned this way. The two bases are the sides that are parallel to each other. That is important. These are not the bases. The height is not necessarily how tall it is, but it is the distance between the bases. Okay, so if it's turned on its side, then that's important. So it's the distance between the bases. Okay, because if you look at it here, then this looks like it's not the height anymore. And we always want height to be vertical and bases to be horizontal, and that's not the case. In fact, this is a really good example of it right here. If you look at this problem, we have our two bases. Remember, the bases are the ones that are parallel. So area is equal to 1/2, and then you've got your base 1, your base 2, and then your height is the distance between the two bases. So base 1, again, it doesn't matter which one's base 1 and which one's base 2. It doesn't matter. So 12 plus 24 times the height, which is 28. Do the 12 plus 24, multiply it by 28, multiply it by 1/2, or divide it by 2, and you get that the area of this figure is 504 yards squared. Okay, number 2, I want the perimeter and the area for this. Notice that we do not have the height, nor do we have these two side lengths, so we need to figure out something. That is where our right triangles come in really handy. This is an isosceles trapezoid, so I know that both of these right triangle wings are identical. This is 60 degrees. I know that I drop this 8 down. That leaves me with two different, that leaves me with 6 to split between the two of these, because 8 and 6 is 14. So this then has to be 3, and this has to be 3. Now that's the short leg. Notice that's 60 degrees. That's important. That takes us back to our x, our 2x, and our x radical 3. So if x is 3, then our height, or our across from the 60, our long leg, would be 3 radical 3. So that means the height of this trapezoid is 3 radical 3. It means that the length of this leg is 2 times 3. So this side is 6 and this side is 6. So the perimeter would be 6 plus 8 plus 6 plus 14. That is 34 units. And then our area is 1/2 base 1 plus base 2. The two parallel sides are your bases, and times the distance between them. That's 3 radical 3. We're going to leave it like that whenever we can. So 8 plus 14 is 22 times 3. So just let the radical 3 go for a ride. That's 66 divided by 2 is 33. So it's 33 radical 3. So that radical 3 is just going to hang on like an x. You would treat it like you wouldn't multiply the x out. We're not going to multiply the radical 3. You could then get an approximate answer, but we'll just leave it like that. Number 3 has, we want our area, again, of our trapezoid. This time we need 1/2, and it's base 1 plus base 2. The problem is we don't have one of the bases. So we know it's going to be plus 5. We know it's going to be times 6. That's our height. So we need this piece. Well, let's go find it. If this is 5, this is an isosceles trapezoid. Again, that's 10 and 10. We need this entire base, but I can't find that entire base. So here's what I want to do. I know this is 5. So we're going to use this little right triangle right here. Always right triangles are our best friends. If you notice, this is 5 times 2. This is 3 times 2. That means this piece must be 4 times 2. That means this piece is 8, and this piece is 8, because both of those have to be the same. If you don't know your Pythagorean triples, this is a 3, 4, 5 triple. If you don't know that, then do Pythagorean theorem. Okay? 8 plus 8 is 16, plus 5 is 21, which means that base is 21. Now we can do 5 plus 21 is 26. times 6 divided by 2. You get 78, and that's meters squared. You can take half anywhere along the way. 26 times 3, you can take half of 26 and get 13, and then multiply that by 6. Just don't take half of 26 and half of 6. Be careful with how you handle that 1/2. If we look at this on a grid, perimeter, so to find the perimeter, I need the lengths of each of the sides. So BC is 1, 2, 3, 4. AD is 1, 2, 3, 4, 5, 6, 7, 8. We like when they're horizontal and vertical because we can just count them. But then I need those sides. So here's what we're going to do. You can draw a right triangle anywhere. It doesn't matter. This isn't a part of the trapezoid, but we're going to use it to find it. This side is 2. This side is 1, 2, 3, 4. So I do Pythagorean theorem. 4 squared plus 2 squared. 4 squared is 16 plus 4. That's the square root of 20. Because I'm going to add them all together, I'm just going to leave it like that. I have 2 of those, so that's the square root of 20. This is also square root of 20. So add 4 plus 8 plus the square root of 20 plus the square root of 20. And you get that the perimeter is 20.9. Then we need the area. Area is 1/2, base 1, 8, plus base 2, 4, times the height. We don't have it, but we can count it, right? There's your height, 1, 2, 3, 4. You can draw your height anywhere, by the way. It doesn't have to be always from corner, okay? But it's height, it's 4. So 12, half of 12 is 6. 6 times 4 is 24. I do it however I need to do it so that I can do mental math. So the area of that figure is 24. So this one is a composite. Composite means it's a shape that's made up of a bunch of shapes. So this is a rectangle, and we're going to cut out a trapezoidal hole. The rectangle is, if we take our rectangle, right, it's 25 by 17, and we're going to subtract away the trapezoid. That's 11. This is 9, so this is 8, because the whole thing is 17, so that's 8. We need this. We have 25 minus this 8, so that is 17. So we've got 17 there, right? We took the 25 all the way across. Take away the 5, take away the 3. That leaves you with 17. The area of the rectangle is 25 times 17. The area of the trapezoid is 1/2 base 1 plus base 2 times the height. 25 times 17 is 425. 17 plus 11 times 8 divided by 2 is 112. And you get then that the area of this resulting figure would be 313, and that would be centimeters squared. So you take the whole area and you subtract it away. If I had a rectangle and I set the trapezoid on top of it, then I would add them together. I would take the rectangle and I would add the trapezoid to it. So it depends on whether you have a hole or an add-on. Okay. Now we've got area of a rhombus and a kite. This is a formula that you're probably not familiar with or as familiar with, but it is a nice, easy one. Remember diagonals. The diagonal goes all the way across from corner to corner. So diagonal 1, corner to corner this way. Diagonal 2, corner to corner this way. Diagonal 1, corner to corner this way. Diagonal 2, corner to corner this way. All the way across, not halfway. Okay, now an important thing to remember, right, and not as far as finding area, but we might need it, is that rhombuses and kites are perpendicular. Their diagonals are perpendicular. The formula that we're going to use for a rhombus or a kite, you don't have to. A rhombus is also a parallelogram, okay? And for a kite, though, the kite's not a parallelogram, so you have to use this one. Area is equal to 1/2 diagonal 1 times diagonal 2. Or you could take diagonal 1 times diagonal 2 over 2. Okay? So let's look at some problems with these. Find the area of each kite or rhombus. So find the perimeter and the area of a rhombus that has diagonals of 48 and 20. Now, this is important because in order to find the perimeter, I need the sides, and I don't have the sides. In order to find the area, I need the diagonals, which I can do. So we can go ahead and do that. Area is 1/2, diagonal 1, 48, times diagonal 2, which is 20. Half of 48 times 20 is 480, and that would be centimeters squared. Okay, so now I need the perimeter. So the perimeter is a little bit different, and this is where you have to remember some things about quadrilaterals. One, that a rhombus's diagonals are perpendicular to each other, and they bisect each other. They cut each other in half. So the 48 goes from end to end. This one looks longer than this one, so I'm going to put the 48 here. So the 48 goes end to end. But what I need is I need to use one of these right triangles. So I'm going to use this one right here. They're all the same. It doesn't matter. But this is 48. Well, that means this is 24 and this is 24. If this is 20, then this is 10 and this is 10. Now, why that's beneficial is that helps me to find this piece right here. If you know your triples, this is a 5 times 2, 12 times 2, 13 times 2 triple. That makes this 26. If you don't know that triple, if you don't recognize it, then you would do 10 squared plus 24 squared is equal to c squared. Either way, you'll get that c is 26. Each of those sides is the same for a rhombus, as I write that. And so each of the sides is 26. 26 times 4 is 104, and that's centimeters. Okay, number 7, this is a kite. I can tell it's a kite because I have two sides the same and two sides the same. So I want perimeter and I want area. Area is easy, 1/2. Diagonal 1 times diagonal 2. Well, there's one diagonal, 1, 2, 3, 4. Here's the other diagonal, 1, 2, 3, 4, 5, 6, 7. Well, half of 28 is 14, so it is 14 units squared for the area. Now, the benefit of that is that created these nice little right triangles, so let's use those to find the lengths of our sides so that we can do our perimeter. This is 2 and this is 3. So 2 squared plus 3 squared is equal to c squared. We get that's 4 plus 9. So c is the square root of 13. So that's the square root of 13 and that's the square root of 13. We don't have to simplify it. We can leave it like that. We can't simplify it anyway. But don't change it to decimals yet. We'll do that later. This side is 2. This side is 1, 2, 3, 4. So 2 squared plus 4 squared is equal to c squared. That's 4 and 16. So that is the square root of 20. So this is the square root of 20, and this is the square root of 20. So the perimeter is 2 square roots of 13 plus 2 square roots of 20. So if you add those together, type them all in, then round at the very end, never as you go, you get 16.2 units around that shape. Okay? You can see already, we've done it a bunch of times, Pythagorean theorem is extremely useful. Right triangles are extremely useful. These last two, I'm going to give you the area, and I am asking you to find the missing dimension. This is a trapezoid, so we will use our trapezoid formula. That is area is equal to 1/2 base 1 plus base 2 times the height. Well, we know the area, we know base 1, we know base 2, and we're looking for the height. So let's write the formula and substitute everything in. 164 is equal to 1/2 base 1 plus base 2 times the height. Now, what I like to do is do all the math I can do. So 12.8 plus 20 divided by 2, I get 164 is equal to 16.4h. Okay, just order of operations. Divide both sides by 16.4, and you get that the height, which is x, is 10. And that would be 10 feet. Okay, you need to write the formula. Okay, one, you got to make sure you're using the right formula. And if you write it, then I can tell and I can help with it if you don't. This is a kite, so you got to recognize the shapes. The area of a kite is 1/2 the diameter or diagonal 1 times diagonal 2. Not plus, times. We don't have a sign there, so that means times, like xy is x times y. The area is 247.5 is equal to 1/2 times diagonal 1, 22.5, times diagonal 2. It doesn't matter which one's which. Now, you can handle this a couple of different ways. It doesn't matter. You can take half of 22.5 and get 247.5 is equal to 11.25x. Or you could multiply everything by 2 and get 495 is equal to 22.5x. Regardless, whichever way you want to do it, it doesn't matter. Deal with that 1/2 by doing the math or by multiplying both sides by 2, the 1/2s cancel. Either way, when you go through and you divide by either 11.25 or 22.5 here, you get that the diagonal, the whole diagonal is 22. And that's in millimeters. Okay, so new formula, diagonal 1/2 of diagonal 1 times diagonal 2, or diagonal 1 times diagonal 2 over 2. And then a trapezoid, 1/2 the sum of the bases times the height, where the height is the distance between the bases, regardless of which way it's turned. It's not how tall it is vertically. It's the distance between the two parallel sides.